A power function is a function of the form f of x equal x to the power n, where n is a positive integer. These functions can be graphed as all basic functions by plotting the points. You can easily check that the point 1, 1 is on a graph, point 0, 0 is on a graph of such function, and point negative 1, 1 is on the graph of the function if n is even, and point negative 1, negative 1 is on the graph of the function if n is odd. Using the definition, we can easily show that if n is even, then the function is even, and that means that the graph of that function is symmetric with respect to y-axis. When n is odd, the function is odd, and therefore its graph is symmetric with respect to the origin. Let's look at the behavior of those functions. Notice that if x is between 0 and 1, then the value of the x to the power n will be decreasing when n is increasing. If you look at the graphs, we have a graph of y equal x squared in blue, y equal x to the 4th in green, and y equal x to the 6th in red. If you look at the graphs of these functions between 0 and 1, you can see that the graph of the x to the 6th is below the graph of x to the 4th, and it's below the graph of x to the second power. The larger exponent of x, the larger value of n, the closer to the x-axis the graph is going to be on the interval 0 and 1. When x is greater than 1, then the larger power of x will result in a larger value of x, and therefore graph of the x to the 4th is above the graph of x to the 2nd, and the graph of x to the 6th is above the graph of x to the 4th. The same behavior we can notice for n odd, and x is positive. For x is negative, we'll have either symmetric image for n even, so the graph looks like the graph of a parabola, and for n odd, the graph is symmetric with respect to origin, so the graph would look more like the graph of the cube function.